Okay, good morning or good afternoon. So, quick review of the linear programming. We'll study it more tomorrow. Don't forget your midterm is tomorrow. So, what I want you to do is do this. Show me the answers tomorrow. So here is a graph of a system of inequalities, and the vertices are identified here, here, and here. So I want you to find the maximum of this function and the minimum of this function. So you're going to have to plug in all three vertices into here and choose the largest one because you're maximizing, and plug all three vertices into here and choose the smallest result because you're minimizing. So have those two answers for tomorrow in class, please. And then this one we'll do all the way through from beginning to end. This one is about a drama club selling tickets. We've actually done this problem before. And pause the video and read through it, please. There's a lot of information here. So the first thing we have to identify are the variables, and that the hints or the clue to getting the right variable is to identify what you don't know and what's important. I mean, we don't know the president of the drama club, but it's not important to know who that is in this problem. We also don't know how many tickets of each kind will be sold, and that is important here. We know how much they cost. But we don't know the amount. And there are two types. There are student tickets and adult tickets. So we're going to let X be the amount of student tickets, and Y is going to be the amount of adult tickets. Now, what are my constraints? Reading this paragraph in order, the first constraint actually occurs in sentence 3. The auditorium can only hold 120 people. So all the kids who come, plus all the adults, they have to stay under or equal to 120. So that's our first constraint. This is like the space constraint. And then the fourth sentence says that they need to take in at least $810. And that connects with sentence 2. Sentence 2 tells us how much money we bring in per ticket. So it's $5 per student ticket, $10 per adult ticket, and that's all the money we're bringing in. We want that to be more than 810. So that's our second constraint. Our third constraint occurs in this sentence. They can sell a maximum of 30 student tickets. So X, remember, represents all the student tickets. X can't be 1,000 because the maximum is 30. So X has to stay under 30, or it could equal 30. And then the adult tickets, at most 90 adult tickets. So that's, again, Y is less than or equal to 90. Finally, our last sentence, a local newspaper journalist is going to cover the play. She writes about 8 words per student and 12 words per adult of those who join the play, who watch it. So how many students and adults should we hope to get to maximize the journalist's article? So that is our final one, J for journalist, and 8 times X, so 8 per student plus 12 per adult. And notice there are 3 variables here. So we're going to plug in X's and Y's to find the biggest J, the biggest article for that journalist. So here's the first part that you need to conquer. And then you would go to Desmos and graph just these 4, just the constraints. We save this till the end. We do these constraints and we find their vertices. And here I've got the graph for us. So here are the 4 constraints graphed, and it's this little quadrilateral, kind of like a trapezoid looking thing, and the vertices are identified. So we use those 4 vertices to plug them all into this. This is the journalist's article. We want this to be the maximum. Oh, excuse me. So 0, 90 is the vertex, so I plug in 0 for X and 90 for Y. And if 0 students show up and 90 adults show up, that article is going to be 1,080 words. To the next vertex, 30, 90. So 30 for X, 90 for Y. If 30 students show up and 90 adults, then there will be 1,320 words. And you keep on going along, covering each vertex, however many vertices there are. And once you've shown your work for all the vertices, you choose the appropriate one. We want to maximize the length of this article. So the most amount of words is this scenario. So we finally answer it in words. We hope that 30 students and 90 adults attend, and this will maximize the length of the article.